Hey everybody, and welcome back to another fun and exciting pre-calculus class. Today we're going to be finishing up lesson number 5 in chapter number 12. We've been talking about the ellipse in the last lesson, and today we're going to be talking about the ellipse again, but we're going to be talking about translating or moving that ellipse. So let's jump into it. We are on page number 241 in your book, 241. So translated origin, what does that mean? That means that the center point of the ellipse is moving. Now, the easiest way to graph these, and there's multiple ways to graph these, but the easiest way to graph these is once you figure out your translation, you just kind of translate the origin. You just move the origin over into another spot. You basically take it from 0, 0, and then you put another crosshair, you put another origin, if you will, and that's just wherever you write in, wherever the translation occurs. I think you'll see what I mean when we actually graph this one. So we'll leave it at that for now, but that's kind of where we're going at the end of the video. We'll be doing that. So table F, ellipse equations with translated origin. So notice our h and our k are still there. So the h always goes with the x and the k always goes with the y. And so everything looks the same here. And then when we get our origin, it's just going to give us this same equation over here. We're going to pull out the translations, the h and the k, and hopefully everything will be good from there. All right, so let's go ahead and jump into it. All right, let's look over here and let's do it. Let's do 9x squared plus 4y squared minus 18x plus 16y equals 11. All right, so lots of stuff going on. I think what I would do first is I would probably complete the square. I think that's probably going to be the best thing. So let's go ahead and put this down as 9x squared. We're moving the negative 18x with that, because this is the piece that we want to complete the first square on. And then we're going to have a plus, and then we'll do the second part, and that's the 4y squared plus 16y. And then we would have our equals 11. Okay, and let me throw a parenthesis on this so that you can see it. All right, so there we go. Now we want to complete both of these, and then we want to add it to the other side. This is just what we did a couple lessons ago, and we're just kind of going back to it now. So what I would do first is I would take out my 9. So I get 9 and then x squared minus 2x. And then I would do the same thing here with my y term, and I would take out my 4. And I would get my y squared plus 4y. And then equals 11 still. Now this is going to get just a little bit tricky here, but I want you to hang in there with me, because this 9 and this 4, because those are out front, those are what we would call like a multiplier. We're going to have to add this over here, but we're going to have to add it with the multiplier of 9. So basically 9 is being multiplied by whatever we take out of that. How do we do this? We take the 2 and we cut it in half, and then we square it. So x squared minus 2x, and then we cut the 2 in half, so 2 divided by 2, and then we square that. So we have to multiply this on the other side by the 9. So what is 2 over 2 squared? 2 over 2 is 1. 1 squared is 1. So we're going to have to add this over here to 9 times 1. Okay? Because of the multiplier, we have to multiply that. So we still have the multiplier over here, and then we have to multiply it by that for it to be equal. We have to have equality over there, right? And so that's added to, and then we're going to do the same thing with this one. We're going to get y, well, we'll have 4 times y squared plus 4y, and then we're going to have plus 4 divided by 2, and that's going to be quantity squared. 4 divided by 2 is 2, 2 squared is 4, so we're going to end up with over here plus 4 times 4. Right? All right, so there we go, and then that's going to equal over here, it's going to equal this mess, whatever that comes out to. So that would be 11 plus 9, 9 times 1 is 9, plus 16. So 11 plus 9 is going to be 20, and that's going to be 36 over there. All right, now let's clean this up just a little bit. Let's kind of deal with this, and what we have to deal with here is that we would have 9 times, and then we're going to factor this out. So what's the factorization of that? That's going to be x minus 1 squared, and then plus, and then we're going to have 4 times, and then over here we're going to have y plus 2 quantity squared equals 36. All right, so we're almost done. The last thing that we really have to do is divide everything, every piece by 36. Okay, and then that's going to make that our 1. That's where we're going to, is we want that to be a 1. So then this one, we could reduce this, and that's going to give us a just our x minus 1 squared over 4 plus, and then we'll reduce these ones out, and this is going to give us just our y plus 2 squared over 9. All right, so what we want to do now is kind of look at what we have. So here's what we have. We have our translation, we have our h and our k. So let's start writing some things down here. So our h is going to equal 1, because we have the negative 1. Remember, the formula is already negative, so it's going to be positive. And our k is going to be negative 2. So k equals negative 2. Then we also have to have our a, our b, and our c. Those are all important numbers here that we have. So don't forget, this one is going to be, in this case, since this one is bigger, a is always bigger, this will be our a, this will be our b. But don't forget, this right now is a squared and b squared. So when we take the square root of 9, we're going to get what? So the a is going to be 3, and the b is going to be 2. So what does that make c? Well, we'd have to come up here and actually do that. So the way we do that is our a squared minus b squared, and we're going to take the square root of that. So the square root of a squared is 9 minus b squared is 4. 9 minus 4 is 5. So we have the square root of 5. And that's going to be our c. So our c is going to be the square root of 5. Now, square roots don't really play well here in this. So what you'd want to do is hit your calculator, and that's going to give us approximately, that's going to give us 2.2. Approximately. We're just rounding off. And this is going to be a little bit better when we go to graph it. It's going to help us out in our graphing when we use the 2.2. All right, so the first thing I want to talk about here as we start to graph it is that our translated origin is going to be 1, negative 2. Okay, so that's our translated origin. That's our origin prime. So again, this is kind of one of those, you can do it several ways, but what does this look like when I get it on the graph? So let's come down here to our graph, and if we translate the origin 1, negative 2, that means that we're coming over 1 and then 2 down. Now, what does it mean to do a translated origin? That means that this point right here, so 1, negative 2, this point is going to be our new origin. So what they tell you to do is take and make that your new origin by putting in like a new cross right there. Okay. In other words, yes, we know that this is 0, 0. Okay. Yes, we know that spot right there. Okay. So that's 0, 0. But we don't want 0, 0 anymore. We want this spot right here, which is our new origin 1, negative 2. So we're going to put our new origin at 1, negative 2. Okay. And that's important to do because it will make everything else easier. Now, there are ways to do it without without doing that right there. So if you don't want to and you want to figure out a different way, that's fine. But I'm just telling you, one of the easiest ways, the way that the book shows, is to translate that origin down 2 spots and over 1 spot. That way it's like you're starting fresh. In other words, on my new focus, on my new endpoints, all of the different things, I don't have to move them. I just have to use this new spot right here. As long as I'm starting from that. So let's say my focus is at 2, 3. I don't know where it's going to be, but let's say it's at 2, 3. I would go 1, 2, 1, 2, 3, and I would know, okay, my new focus is right here. And you might say, well, that's not 2, 3. It's 2, 3 on our translated origin. That's what we're worried about. And it's not confusing, and it is confusing at the same time. So whatever you want to do there is kind of up to you. You can figure it out. So let's just kind of leave that there now that we have our translated origin. And let's go back and let's figure out what is the focus and what are the endpoints and what's everything else that we need. All right, so we're going to need our focus. We're going to need our minimum endpoints. We're going to need our lattice rectum length and our lattice rectum points. All right, that's what we're going to need in order to be able to graph what we need to graph. It was easy when it was a circle, right? Because everything was the same distance from the center point. This is not the same distance from the center point. We're going to need all of these other things in order to get it onto the graph. You might say, I don't really need the focus, and you might be right, but we're going to write the focus on here. These other pieces are critical in getting our graph to be correct. Okay, so what's the focus? I kind of left all this up here from the last lesson. Our focus is, well, first of all, you have to say, what are we dealing with? Are we dealing with a horizontal or are we dealing with a vertical? And in this case, remember our A was bigger on the Y, right? Our A was with the Y. So we're dealing with a vertical. So we're going to be using this side this time. So our focus, our foci, are going to be 0, C, and 0, negative C. So we're going to come back down here, and our focus is going to be 0. Change the color here, so it's going to be 0, comma C, which is 2.2. And again, that's just going to be a little bit easier, and then we're going to have 0, negative 2.2. That's going to be just a little bit easier than dealing with the square root of 5. You might say, I don't even know what the square root of 5 is. Okay, exactly, that's the point. It's not really even a number that you can use when you're graphing, so always do the approximate on the square roots. It's just going to help you. Now, the minimum point. So let's go back up. How do we do the minimum point? There it is right there. Remember, we're on the vertical side, so we have B0 and negative B0. So B0, B is 2, so we have 2, comma 0. And negative 2, comma 0. And those are going to be our minimum points. All right. Then we have our lattice rectum length that we're going to need. So we have this cute little formula here, right? It's the same on both sides. 2b squared over a. 2b squared over a. So let's go ahead and work that out. 2b squared over a is going to be 2b is also 2 squared over a, which is 3. So 2 times 4 is going to be 8 over 3. That's going to be our lattice rectum here. That's our length, 8 over 3. Now, in order to put them into the lattice rectum points, we need to take this 8 over 3 and cut it in half. Remember that? So let's go back up here. We're going to cut it in half, and it's going to be that lattice rectum length in half, comma C. Remember, we have to do it positive and negative. This should actually have a negative sign with it. Sorry about that. But there's a positive and a negative here. And then these have to be positive and negative points. So we're going to get 4 of these. So we're going to have 8/3 divided by 2. Let's do that over here. 8/3 divided by 2 means times 1/2. That's going to cancel out to a 4. And that's going to give us 4/3. 4/3 is like 1.25. That would be the easiest way to do that. So we will do 1.25. So we'll have a positive 1.25 1.25 comma c. We'll have a negative 1.25 comma c. We'll have a positive 1.25 comma negative c, and then we'll have a negative 1.25 comma positive c. Okay. Now let's go ahead and sub in the c. The c is 2.2. So remember, we're going to have positives and negatives over here as well. So 2.2. Then we're going to have a positive 2.2, and then we'll have a negative 2.2 and a negative 2.2. All right. So there we go. There are all of our points. Now, once we go ahead and graph all of these points, we will get our ellipse. And actually, one more thing that we're really going to want is we're going to want the vertices too. And we have the translated vertices, but we're going to want, we have our translated origin, but we want the vertices too. So let's go ahead and do that real quick so that we can start off with those. So it's 0a and 0 negative a. So that's going to be our vertices. I should have done that one first, but I didn't. So there's our a. So it's going to be 0, 3. And 0, negative 3. Okay, there's our vertex. We have two vertex, so vertices. All right, so let's go ahead and start putting these points down on our graph. All right, now I'm not going to go back and forth. It's just going to take too much time, so I'm actually just going to start plotting these. You can look at your book or you can look at your notes that you've been taking. So the first thing is we want to do our vertices, and we're going to, again, this is our new origin. So our vertices are going to be at 0, 3 and 0, negative 3. So we're not going anywhere right to left. We're just going up and down here. So 1, 2, 3. There is one vertex. And then 1, 2, 3 down. There is our second vertex. What does that mean? That means that this is the point that this thing's going to be bending on right here. Okay. All right, so the next thing is our focus, and we don't really need our focus to graph, so let's leave our focus alone for right now. We'll kind of put that in just a second once we go from there. So I'm going to change my color for the next one. Let's go ahead and do the minimum points. So that's going to be somewhere over here on these sides. All right, and that's going to be 2, 0, so 1, 2, and we're not moving up or down. And then that's going to be negative 2, 0, and we're not moving up or down. So there we go. Now, really, we kind of have enough points right now to start graphing it. You know, we don't know what the exact curve is going to be, but we could kind of start filling it in, right? But we have some more points that we could use to even give us a better graph right here. What do we have? We have these right here. These are the lattice rectum points. So we have 1.25 and 2.2. So let's go ahead and use those. You know, every once in a while I mess up as a teacher too, and I messed this up. When I had this right here, I made that to be 1.25, and that should actually be 1.3, 1.3, 1.3. That's 1/3, not 1/4. Sorry about that. Not a big deal. I would not have marked that wrong on your graphing because it's really hard to tell the difference between a 0.5, so it wasn't that huge of a deal, but it was still a big deal, so sorry about that. I messed that up. So we are going 1 and 1/3, so 1 and 1/3, so just a little bit, and then we're going 2.2, and we have to go up 1, 2, and then 0.2. So we're going to get a point like right here, and then we're going to do the same thing. We're going to go down, so 1 and 1/3, so right there, and then 2 down, 1, 2.2 is going to be somewhere right in here. And then we would do the same thing on the negative side. We're going to go 1 and 1/3, and then we're going to go 2 right there somewhere. And then we would do the same thing, 1 and 1/3, and then we're going to go 2 up and a 0.2, so right there. And what those are is those are the ends of the lattice rectum, okay? And now we could put our focus in there if you want to. The focus was the 2.2. So that focus point, let me change it here, would go right about here. And this focus point would go right about here. So the focus would be this line and this line. So the lattice rectum would be this line and this line right here. We don't need those lines. I'm just kind of throwing those in there. So now let's go ahead and build our ellipse. So there we go. We'll just kind of sketch it down and around here. There we go. It's not too bad. So there's our ellipse. We've used our main points and we've built our ellipse. All right, real quick, let's jump over to your book and let's look at example 3. Example 3 is basically what we did quickly in the last second part of the last lesson, and we're going to build the equation. Find the equation of the ellipse with the foci 2, positive, negative 3, comma 2, and then whose minor axis has a length of 8. You're just going to work all of that backwards. And I know it sounds a little bit complicated, but just remember what your formula looks like. All right. Remember what your how you get your H and K in the focus. Remember how to get your C and work your way backwards, and then build your new equation and just work through that solution right there. And I think that should make a lot of sense to you. So there it is. I hope you understood that. If you didn't, slide it back, watch it again. There is a lot going on there. I make mistakes too. We all make mistakes. It's okay. Just recognize your mistakes. And this is a lot of different math going on and a lot of different things to keep track of. So there's no surprise that, there's a little mistake in there and it throws the whole thing off and it's like, what is going on? Well, try to focus on the main things that I showed you. Make sure that you remember the key places where I said a lot of students make mistakes right here. So make sure you're squaring and taking square roots and all the positives and negatives and all that good stuff, and just kind of work through it. Take your time, check your work, go back through the video, go back through the steps in the examples, and try your best and work through these. All right, that's all I've got for you. Hope you learned something there. We'll see you later. Have a good one. Bye-bye.